Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture under preparation of alkenes, I am going to explain some important points on acid catalyzed dehydration of alcohols and some important questions on it. So what are alkenes? Alkenes are unsaturated hydrocarbons having at least one double bond. Its general formula is CnH2n. For example, if you are having this one, CH2 double bond CH2, how many carbon atoms are there? 2 carbon atoms are there. How many hydrogens? 4 hydrogen atoms are there. So here N is equal to 2. Its IUPAC name is ethene. Similarly, alkenes having 3 carbon atoms, for example CH3, CH double bond CH2. Here molecular formulas 3 carbon atoms, so 3 C3 and H how many? 3, 4, 5, 6. So here N is equal to 3. C3H6. Its IUPAC name is propene. It is having 3 carbon atoms. Similarly butene etc. are there. So under general method of preparation, first method is acid catalyzed dehydration of alcohols. What is dehydration? Dehydration means removal of water. Now see sulfuric acid, phosphoric acid, and this is para-toluene sulfonic acid. These are dehydrating agent. Dehydrating agent means it can remove water. Now note down alcohols on heating with, this is heating symbol. Alcohols on heating with concentrated sulfuric acid, phosphoric acid or para-toluene sulfonic acid form alkenes with elimination of water molecule. Since elimination of water is taking place, so this is called dehydration of alcohol. And acid is used as catalyst here. If you see its mechanism, actually mechanism is E1 mechanism. Mechanism I am not explaining. You can see H2SO4 is used at the beginning and it is regenerated at the end. So it is catalyst. For example, if you are using sulfuric acid. Now take one secondary alcohol. Why this is secondary alcohol? This carbon where OH group is attached, with this carbon 2 more carbon atoms are attached. So this is secondary. Here you have to use dilute sulfuric acid. Suppose 60% H2SO4. Temperature is 100 degrees centigrade, means boiling dilute sulfuric acid. So what will happen? Removal of water takes place from here OH and from here or here H, because these two are symmetrical position. We will get CH3 CH double bond CH2 means propene plus water. So this is also alkene. If you take tertiary alcohol, so this is propan-2-ol. Propan-2-ol. Now see this is your tertiary alcohol, because this carbon is attached with OH and this carbon is attached with 3 carbon atoms, means this is tertiary carbon. So this is tertiary alcohol. Its IUPAC name is 2-methyl propan-2-ol. 2-methyl propan-2-ol. If you treat this tertiary alcohol with 30% sulfuric acid around 90 degrees centigrade heating, so here what will happen? OH from here and H from here, here or here, because all are symmetrical position will go, and we will get CH3, C double bond CH2, CH3 plus water, isobutene plus water. Now see, here this reaction is taking place at 170 degree centigrade, but for secondary alcohol temperature is 100 degree, so it is lesser than this, and for tertiary alcohol also temperature is lesser than this. So you can conclude that tertiary alcohol is much more reactive for this reaction than secondary alcohol, and secondary alcohol is much more reactive than primary alcohol. Because the mechanism of the reaction, as I told you, is U1. Mechanism I am not explaining. So reaction is taking place via carbocation formation. So the more stable the carbocation is, the more easily the reaction will take place. So you know tertiary carbocation is much more stable than secondary. Secondary is much more stable than primary. So this is the rate of dehydration reaction. Another thing you have to remember, for secondary and tertiary alcohol we are using dilute sulfuric acid, but for primary alcohol we are using 95% sulfuric acid, because alkenes produced from secondary and tertiary alcohols tend to polymerize under the influence of concentrated sulfuric acid. So what will happen if here you will use concentrated sulfuric acid? Polymerization of these alkenes take place. So to avoid this polymerization reaction, here dilute sulfuric acid you have to use for secondary and tertiary alcohol. Now remember, since this is elimination reaction, so heating is required, and here this is secondary alcohol, because see this carbon is attached with two more carbon atoms where OH group is attached. So since secondary alcohol, so here on the arrow you can write dilute sulfuric acid. Now see, here with respect to this OH, this carbon is alpha and next carbon is beta. Here also this carbon is beta. This is alpha, this is beta. So here beta hydrogens are there into different environments. So this OH and this H can go. In that case we will get CH3, CH2, CH double bond CH2, and if this OH and this H will go, we will get CH3, CH double bond CH, CH3. So here we will get a mixture of two alkenes, and see which one will be the major product here. In this case, Sedgep's product will be the major product. So which one is the major product? More substituted alkene. This is more substituted alkene. So this is your major product, and this is less substituted. So this will be your minor product. So here you are getting mixture of alkene. Why this is major? Now see, with respect to this double bonded carbon, this position is alpha, this position is alpha with respect to this double bonded carbon. So here 3 into 2 means 3 to the 6 alpha hydrogens are there. And here with respect to this double bonded carbon, this carbon is alpha and 2 alpha hydrogens are there. So which one is major product? Where more alpha hydrogens are there. So means the alkene will be the major product where more alpha hydrogens are there. So this will be the major product according to Sedgep rule. And this dehydration of alcohol is beta elimination, because beta hydrogen is eliminated. Beta with respect to this OH. This is example of beta elimination. So we have seen mechanism for the reaction is U1. U1 elimination is taking place. Since carbocation is formed as reaction intermediate, so if possible carbocation rearrangement takes place to form more stable carbocation. For example, now see, this is 1 degree alcohol. So under this reaction condition, what will happen? Oxygen is having lone pair of electron. That lone pair will be donated to H plus, and we will get here CH3, CH2, OH2 plus. Then removal of this part will take place and we will get this carbocation. Now see, with this carbon atom where positive charge is there, one carbon is attached, so this is 1 degree carbocation. So here tertiary carbon is there, so this methyl group can migrate with its bonding electron here to form CH3, CH3 plus here CH2, CH3. So what is happening here? 1,2 methyl shift is taking place. Carbocation rearrangement is taking place. Now this carbon is attached with 3 more carbon atoms. So this carbon is tertiary, and we know tertiary carbocation is more stable than primary carbocation. Now we are having this more stable carbocation. So here after methyl shift we are getting this carbocation. Here with respect to this carbocation, this is alpha, this is alpha carbon. This is also alpha, but this and these two are same. So maybe hydrogen can go from here or hydrogen can go from here. If hydrogen will go from here, we will get CH2 double bond C, CH3, CH2, CH3. And if hydrogen will go from this carbon, we will get this alkene. So here with respect to this carbon-carbon double bond, this is alpha carbon, this is alpha carbon, this is alpha carbon. So how many alpha hydrogens are there? 9 alpha hydrogens are there. And with respect to this is alpha, this is alpha. So here 5 alpha hydrogens are there. Obviously this is more stable. Therefore this will be your major product and this is your minor product. So what you have to do? Generate carbocation. If by rearrangement more stable carbocation you can form, do that one. Then eliminate alpha hydrogen with respect to this carbocation. So two different types of alpha hydrogens are there. We can get these two products. This is major, this is minor. Now on this topic we will solve two problems. Arrange the following alkanols ABC in order of their reactivity towards acid catalyzed dehydration. Alcohols are given. Now see here, reactivity order for acid catalyzed dehydration we have to find out. We know rate of the reaction is proportional to carbocation stability. That means if carbocation is more stable after removal of H2O plus, the rate will be much more faster. So from here, after protonation and removal of water, what carbocation we will get? This carbocation, which is 1 degree. Here, after protonation and removal of water, what carbocation we will get? CH3, C plus CH3, CH2. So this carbocation is, you can see this is tertiary because this carbon is attached with 3 more carbon atoms. And from here, after protonation and removal of water, what carbocation we will get? CH3, CH, CH3, CH plus CH3. So this carbocation is secondary because this carbon is attached with 2 more carbons. Now you have to consider that carbocation which is generated first after removal of H2O plus. Don't consider the carbocation which is formed after rearrangement because see there is chance of rearrangement. So don't consider that one. Only the first carbocation whatever you are getting, consider that one. This is 1 degree, this is tertiary, this is 2 degree. We know stability is like this. This and this. This is the stability order. Therefore, Reactivity order is also first B, then C, then A. This is your answer. Now here the major product in the following reaction is, one reaction is given. This is one alcohol. So on the arrow it is written H plus heat. So what will happen? Dehydration of alcohol will take place and we will get alkene. So first protonation will take place. We will get this protonated alcohol. Removal of H2O plus will take place and we will get this carbocation. Now see here, to satisfy the valency of carbon, one hydrogen is there. So what will happen? Migration of this hydrogen with its bonding electron takes place from here to here. That means here what is happening? 1,2 hydride shift. If 1,2 hydride shift is taking place, we will get this carbocation. Now see, this is 1 degree carbocation and here we are getting more stable tertiary carbocation. Now we have to find out the major product. Major product means most substituted alkene you have to find out. So from here if hydrogen will go, we will get this alkene. And if hydrogen will go, we can get this alkene. So your product is either this one or this one. Now see here, with this double bonded carbon, this carbon is attached, this carbon is attached, this carbon is attached. So it is tri-substituted alkene. With this double bonded carbon, this carbon and this carbon is attached. This is di-substituted. So which one will be the major product? More substituted alkene is the major product. So this is your answer. In this video till this, if you like, please subscribe. Thank you for watching.